Hello students, I wanted to take a few minutes to talk about computers and their influence on geospatial technologies and to get a little bit under the hood in terms of the foundations and technologies that have so transformed our world. I guess I should start off by saying that I have a long history with computers. I have a computer science degree from Cal Poly. And I graduated from high school in 1981, which was the year of the personal computer revolution. IBM's personal computer was released in 1981, and when I left high school, I had never sat behind a computer before. My father recommended computer science because I was reasonably good at math, and proceeded to get a crash course in the then latest technology, which evolved extremely rapidly. We went from using card readers and vacuum tube computers to the graphical user interface, the GUI, that is the common interface on computers today. The precursors were actually developed by Xerox, of all companies, the photocopier company, and subsequently adopted by Apple, which was then adopted by Microsoft, and of course the rest is history. So I'm going to run through some technical aspects of computers and talk about and demonstrate a few things that you'll find on your computer, and hopefully inform your understanding of computers that, of course, you interface with all the time, and also give you a little bit of that sense of how this is going to relate specifically to the use of geospatial technologies. So this diagram, actually there are two diagrams here, so let's start with the diagram on the right here, which is fairly simple and dating back to my earliest days in computer science. We learned that computers are comprised of input devices that allow us to input information, output devices which are used to send information back out, so you can output information through the computer monitor, and you can also output it from something like a computer printer. And then you have this main system unit, which will include the various items that are shown on the left. Of course, there's a variety of storage devices that are available, but once you get into this system unit, generally, and again, these are highly variable now, a lot of new computers are not including the CD-ROM DVD player, for example. All computers will include the central processing unit, generally some kind of a cooling system. One of the challenges with laptops is keeping them cool because we don't have as much physical space to be able to store a fan or to generate air that these systems need to cool down. The hard drive is the internal storage device, and so we'll take a look at how that we see that on our computers from a software standpoint in a moment. Here's our input device, memory storage. And there's a distinction to be made, and again I'll talk about this in a few minutes. Hard drive is considered long-term storage, memory is considered short-term storage for immediate processing. This shows a modem. This is a bit of a dated term these days. Modems aren't used as much. Network cards are more common. Of course, you can also have a Wi-Fi enabled device. I'm going to talk a little bit more about the motherboard in a few minutes, but as the name implies, this is sort of the mother, the center of the computer. This is where the actual computing takes place. We talked about monitors. This diagram is a little bit dated. As you can see, we're almost entirely have gone to flat screen monitors. Power supply, usually have a pretty fat plug on the back because these things suck a lot of energy and generate a lot of heat. Sound cards and video cards, of course many people are using these devices for home entertainment, but video card in particular is a really important element for geospatial. So anytime we're working with imagery or we're bringing in large complex maps, the video card is going to be put to work. And so if you are buying a computer and you're thinking about what should I be looking at in terms of being able to do GIS, video card is definitely something to look at. And you can look at computer specs from ArcGIS or from Esri, for example, if you want to get some more details on that. Okay, so I want to walk you a little bit back through time. I recently attended the memorial service for Chuck Hornbeck, who had a full life. He died at 88 years old. You may have heard of the Hornbeck Trail in Reading, which was named after him, and he was a surveyor and a civil engineer, and as I learned at his memorial service, one of the first people in Northern California to have a computer. And we saw on display an early surveying computer device that he had created. And on this particular backside of this computing device, you can actually see these lit diodes that are actually named, and these were how they were doing these computer processing. And quite primitive, but really quite remarkable as well to think that this was literally among the first computing devices in all of Northern California. And you think about how widespread and how many of these devices are present today. So computers are built on the foundation of the integrated circuit or the microchip, and I have a definition there. And it's a fascinating story. I give you the date of the invention of the integrated circuit in 1959, and this is something that revolutionized. These were not the first computers, but once the integrated circuit was developed, it allowed for a tremendous downscaling in terms of size and increasing in the number of commands that could be processed by a computing device. And the background of this image, so let me just kind of carry you through this. So this is an example of a microchip or an integrated circuit that would sit on a motherboard, and you're transmitting devices over these little silicon strips that are communicating this information. You can see it again on this diagram, and these have the ability to communicate signals, and those signals are communicated generally as, or translated anyways, as ones and zeros. And so when you hear that term binary, that refers to a number system that has two digits, a 0 or a 1. Now it turns out that you can combine these. So if you had 8 of these, which is actually what's defined as a byte, B-Y-T-E, 8 of these single digits would comprise a byte, and from that you can produce 256 different values. And so this is basically how we scaffold up from the computer hardware into software and ultimately all of the computing capabilities that we have today. In the lecture you learned about Moore's law, and again this was illustrated a little bit in the picture that I showed you a few minutes ago from old Chuck Hornbeck's primitive computer. And if we take ourselves back to the year 1970, you can see that the number of transistors that were found on an integrated circuit were in the order of 1,000. When I started my computer science degree, that leapt up to 100,000. By the time I had graduated from school, that number was pushing 500,000 in 1986. And we leap ahead to when I completed my master's degree, and we were up to 10 million. And you can see this just exponential increase in the capacity to the point where by the year 2016, we were storing 20 billion of these transistors on a microchip. And so I actually have a friend who was a mechanical engineer and went to Asia to set up manufacturing plants building computer chips. And he was talking about some of the physical barriers and limitations that they had to get past to be able to continue this increase in the miniaturization of the transistors themselves, which of course increases the processing speed and the capacity of computers. You see a similar increase in storage capacity. So we'll look at some of the storage capabilities of the computer that I'm running on, and I'll talk a little bit about some of the places we've come from. A bit of a crude diagram here, but the way you want to read this is that I just talked to you about computer hardware, and if you look up at the next level above this, we have what are called systems software, operating system being the most common of these, and I'll give you a little demo on the computer here in a moment, but you see various utilities and compilers and assemblers and file management tools. And these are some of the things that someone in a computer science degree, for example, would learn how to really access and manage and control at sort of a lower level. And then you have the application software, and these are things like graphics programs. If you're doing something like Adobe Illustrator, everybody's writing papers in Word, spreadsheets, communications, databases, gaming. Now, what is not illustrated here is cloud computing, which is relying on using a connection to the internet through Wi-Fi or through computer networks and receiving that information. For example, I could go to Google Docs and I could run word processing functions on the cloud, which is distinct from having a application installed on the computer that I'm running at. So just a distinction to be made there. So computer networks, this has really revolutionized our what we can do with computers. I can remember way back in the day in probably 1983 taking classes that were about how to communicate between computers and between servers, and developing a protocol from which messages and commands were sent to communicate between devices that are hooked up to a network, which is kind of how this works. So you see, like a server rack. Of course, the cloud is basically a bunch of these servers, and it runs through switches, and then those switches could feed out to computer workstations. If you're working in a big organization, those are probably passworded. They probably limit the commands, so different employees may have different privileges that are set up by this system of software, and all this stuff links together. As I mentioned, of course, the cloud, and I had a student today tell me they enjoyed the article on the cloud, sort of finding out that it's not this kind of ephemeral, poofy thing in the sky, but rather nuts and bolts hardware, buildings, fiber optic cables, and what have you that make this cloud operate. So, in the lower right-hand corner, an image from Salesforce that kind of shows how various players from Microsoft to Amazon and Google, IBM, and so forth use different aspects of the cloud. Salesforce being a company that provides this sort of cloud-based communication, storage, enabling of different business operations. You could never have an Amazon without the cloud, for example. And then, of course, an image of a data center on the left-hand side. As we found out, these are massive structures that use huge amounts of energy and with lots of infrastructure, cabling and whatnot, fiber optic systems, as you learned in the article today. So, of course, so many great things that this computer revolution has brought to us. It has also brought negatives, including e-waste and a power demand that is exacerbating climate change as an example. Another aspect of this that there's a lot of questions being raised about is how the effect that using computers all the time, especially mobile devices and so forth, is affecting people's brains, especially young people. It's affecting how we socialize with one another. There are lots of aspects of this that we need to be cognizant of and keeping in mind as we move forward. Okay, so with that little intro, let me just run through a couple of things that I wanted to show you and see if I can figure out how to shut my presentation off here so we can talk to my computer. There we go. So I'll go ahead and minimize that. So I had a lot of stuff open. So I'll just minimize various things on my screen. And I'm going to start off by just looking at the properties of my computer. And I've just opened Windows Explorer, so you're probably familiar with Windows Explorer. And I'm going to start off, you can see there's various things that I can do when I right click, but I'm really interested in looking at the properties. And this tells me the properties of this particular Shasta College computer that I'm running on. So it tells me the operating system that I'm running from, the service pack, which is kind of the updates to the operating system. So Windows 7, this is what's called the Enterprise Edition, which is designed for multi-user enterprises. Shasta College is a great example. Lots of people, different entities. I'm plugging into a network. I'm plugged into a network as we speak. And as we run down this thing, you can actually see some specifics about the computer itself. So the processor, this is what would be called your central processing unit, your CPO, or your CPU rather. And you see that I have an Intel Core processor that has this kind of code identified. Intel's the long-standing chip maker, and it gives me clock speed in gigahertz. So 2 gigahertz clock speed tells me how fast it can process individual commands. It tells me the amount of internal storage memory that is available on this computer, and now Moore's law comes into effect. So if I look at this, it says that there's 12 gig. Let me run through the end of this and I'll come back to that. 64-bit, okay, so ones, zeros, so a bit is a single storage of a 1 or a 0. So I've got 64 of those across, so as many values as a 64-bit sequence of ones and zeros can produce gets you into, again, a reflection of speed of processing of and complexity of commands. So let me jump back over here for a second, and I'm going to go to the properties of, let me go to the properties of my local hard drive, because that's where I do my storage, right? So I'm going to go to properties of my storage, and this tells me that I have a disk space. I have a capacity of 167 gigabytes of storage. And so, again, byte, a sequence of 8 ones and zeros, right? And so those represent, you can store a certain amount in 1 byte. Well, a 167 gigabytes is a prefix of, well, let's do this. So a giga do metric giga. I should be able to remember this, but I'm blanking out on the exact factor. That one will probably be pretty good. Yeah, here we go. So if I look at a gigabyte, I am looking at a 10 to the 9th number of bytes. That's a 1 followed by 9 zeros. Just for context, you see that a megabyte is only a 10 to the 6th, so a 1 and 6 zeros. So if I go back to my hard drive, okay, so if I go back to my hard drive, I could go and look at a picture that I have on my, and there's a picture that I took recently, and I could look at the properties of this picture. And this is a kilobyte, 1 kilobyte, so about 1 megabyte. My first computer that I bought, which was probably in 1987 or 88, had a 20 megabyte hard disk, which basically means that I could store 20 pictures this size on the entire computer, and that was it. So just to give you a sense of how things are changing. Again, I've got 167 gigabytes. So, you know, I'm on a network, so that's what this network drive is referring to. So, all right, so let me show you something else that I think is kind of interesting. You know, we're used to this, what's called the GUI, the graphical user interface, and we're used to kind of dragging these sort of things around on our desktop and seeing pictures that tell us what we're doing. Well, for most of the early part of my computer career, everything ran from what was called a command line, and you can still run this within well, Microsoft 7 in this case. And so, for example, I could come through and run a command. Like I just ran a command from memory. It's been a long time since I ran a command line, but this is a directory command. It goes through and tells me some basic directory stuff about, for example, the documents directory. And so I might be able to specify and look at the documents directory. There it is. Okay, so within my documents directory, now I'm able to see what are the things that I have listed underneath my documents directory. There are some old school folks that still like to run from a command line because it gives you this sort of maximum control, and programming is part of that, right? So there are small programs that I could run within here, but I'm going to run you over to ArcGIS for a minute now. And so here I've got a map of actually a series of data that's available called Natural Earth. It's quite good. I'm actually looking at the country of Nigeria here, and as I zoom in, I see lots of really meaty data. And of course, I've got lots and lots of commands that I can run that would allow me to work with this data. So I could do various geographic analysis. And again, this is a graphical user interface. So you know, I just launch a command. It's kind of a point and click operation if you know what you're looking for. This is application software, and it's quite complicated application software. And it turns out that, again, I could get under the hood with this thing, and I could run programming through a language called Python. And if you want to know what that looks like, I could come in here and say, that's not the one I was looking for. Well, let's go back to where I was a minute ago. So let's go back to this erase command. Okay, so if I went to the tool help, it would tell me, you know, basically how this works and the inputs and outputs. But if you scroll down, it actually see that there is a syntax for a computer command. Okay, and then I scroll a little bit further down, and now I can see here is the Python code. And that Python code allows you to customize and really get into how this command operates, and to sort of use maximum specifics of controlling what it is that you're trying to accomplish. And increasingly that sort of control and customization is something that's really quite in demand, because every organization has their own needs. And so the one size fits all of the commands that ESRI provides might not be sufficient. So again, that's an example of applications. You can see, you know, I've got a wide variety of different applications that are all running. And again, these are just going to be running resident on my computer. And, you know, again, I could get in and look down at more of a, you know, at this command prompt. Now I'm getting more down to the system software side of things, right? Controlling how the system operates. Windows Explorer would be doing a similar thing, and that is scaffolded or built upon top of this basic hardware construction that I illustrated at the beginning. All right, well, that's the end of my short overview. So hope you got a few things out of this, and I'm going to ask you guys, give you the opportunity to shoot me a couple questions, and look forward to chatting with you online.